Hey everyone, and welcome to the Deep Dive. Today we're diving into something that's become so essential to our lives.
Yeah.
It's almost invisible. Networking. I mean, we use it every day,
Yeah.
but most of us probably don't think much about
That's
how
true.
it all actually works. Luckily, our listener sent us a great source, Networking Basics Simplified.
Perfect.
So that'll be our guide for this deep dive. We'll try to break it all down in a way that makes sense, even if you're not a tech expert.
Sounds good to me.
Let's jump right in. So you're online.
Yeah.
You want to check out a website, like let's say Google.
Sure.
You type in google.com and bam, you're there. But have you ever thought about how your computer actually finds Google?
That's a good question.
It's not like there's a physical map to the internet, right?
Right. No physical map. That's where DNS comes in, the domain name system.
DNS.
Yeah, it's like a giant phone book for the
Yes.
internet. Constantly updating, too. We humans, we use names that are easy for us to remember, like google.com.
Makes sense.
But computers, they think in numbers.
It
IP
doesn't matter.
addresses. IP addresses.
They're sequences of numbers. So DNS translates those human-friendly names into those IP addresses that computers understand.
So it's like DNS is the translator.
Exactly.
Making sure we humans and computers can actually talk to each other.
That's a great way to put it.
It's a pretty clever system.
It is.
Yeah.
And there's more to it than just simple translation.
Really?
Remember those different types of DNS records?
Oh, yeah, the source mentioned those. I was kind of skimming over that part.
It's worth diving into.
Okay, so what's the deal with those records?
Well, think of it like this. A plain DNS record, it's like a basic listing in the phone book, name and number. But then you have these other records that add more information, like an MX record. Ever wonder how your emails get to the right place?
I guess I just assumed they do.
Well, MX records are a big part of that. They tell email servers where to send your messages.
So it's like a special instruction just for email.
Precisely.
Oh.
And then you have things like TXT Record.
TXT records. Those sounded kind of technical. They are, but they're actually super useful. It's like adding little notes to the phone book listings. They can do things like verifying you own a website,
Oh, interesting.
or even help with filtering out spam.
Wow, so these different records, they're kind of like the unsung heroes.
I like that. Unsung hero of the internet.
Keeping everything running smoothly.
They're essential.
So we've got domain names being translated into IP addresses. But I have to ask, what exactly is an IP address?
Well, an IP address, it's like a unique digital fingerprint for your device.
A fingerprint.
Yeah. Think
Yeah.
about it. Your laptop,
Okay.
your phone, your tablet, even those smart refrigerators everyone jokes about, they all need a way to be identified on the network, and that's their IP address.
So it's how the internet knows which device is which.
Exactly. Kind of like when you order something online, you give your address so the store knows where to send your stuff. Same idea with IP addresses, but for data.
So every time I'm streaming a movie, my IP address is basically shouting, "Hey, Netflix, the next episode goes here."
Pretty much. And just like street addresses can be written in different formats, IP addresses have their own dialects. The old school IPv4, those are like the classic phone numbers we're used to.
Yeah.
But there are only so many IPv4 addresses out there, and with so many devices coming online these days.
It's like we're running out of phone numbers.
Exactly. So we're moving towards a newer system called IPv6. Think of it like we upgraded to phone numbers that could accommodate every person on Earth.
Wow, that's a lot of numbers.
Plus their pets.
And their pets.
Yeah.
That's impressive.
Right. So IPv6, it's a much bigger system that gives us plenty of room to grow.
Makes sense. We got to keep up with the times.
We do.
Okay, so we've got all these devices with their unique IP addresses, but how do they actually talk to each other?
Good question. That's where TCP/IP comes in.
TCP/IP. Now we're getting into the technical stuff.
It might sound complicated, but it's really just a set of rules or protocols.
Protocols.
Yeah, like guidelines for how data gets sent over the internet. It's kind of like the grammar and syntax that makes a language work.
So it's like the language of the internet.
Yeah, you could see that.
TCP/IP.
Yeah.
It sounds like more than just one thing, though. What are the different parts?
You're right. TCP/IP has two main parts, TCP and IP. TCP stands for Transmission Control Protocol.
Transmission Control Protocol.
It's all about reliability. Imagine you're sending a super important package.
Like something fragile.
Yeah. TCP is like that super careful postal service that tracks the package every step of the way, making sure it arrives in one piece and in the right order.
So TCP is like the careful one, making sure everything gets there perfectly.
That's a good way to put it.
Okay, got it.
Yeah.
What about IP?
IP stands for Internet Protocol, and it's all about addressing and routing.
So it's like the GPS of the internet.
Exactly. IP figures out the best path for your data to travel and makes sure it gets to the right destination.
So TCP makes sure the message is perfect, and IP gets it where it needs to go. Teamwork.
They work together seamlessly.
But with all this information flying around, isn't it kind of vulnerable? How does it all stay secure?
That's a great question, and it brings us to the difference between HTTP and HTTPS.
HTTP versus HTTPS. I've seen those little letters around, but never really thought about what they mean.
Well, HTTP, that's the basic protocol for web traffic.
Okay.
But HTTPS, that adds a layer of encryption for security.
Encryption. Like a secret code.
Exactly. HTTPS uses something called SSL/TLS to encrypt the data being sent back and forth. So it's like sending a secret message that only the sender and receiver can read.
So HTTP is like sending a postcard that anyone can read, and HTTPS is more like sending a sealed envelope.
That's a great analogy. And that extra layer of security, it's super important when you're dealing with sensitive information online.
Like when you're shopping online.
Yes, especially when you're shopping or banking online. Always look for that little padlock icon in your browser's address bar.
Oh yeah, the padlock.
That's the sign that you're on a secure HTTPS connection.
Got it. HTTPS means my online shopping sprees are safe from prying eyes.
Exactly.
But all this talk about data traveling makes me wonder, how do websites handle all that traffic?
Good question. Especially popular websites, they must get bombarded with requests constantly. What keeps them from crashing?
Yeah, I've never really thought about that.
It's all thanks to load balancers.
Load balancers.
Think of it like a busy restaurant with a sudden rush of customers. If all the orders went to a single chef, things would get backed up fast. So load balancers, they distribute the traffic across multiple servers. It's like having several chefs in the kitchen so no one gets overwhelmed.
Oh, that's a good analogy.
Yeah.
So load balancers are like the traffic cops of the internet, making sure everything flows smoothly.
That's a great way to think about it.
So I've heard there are different kinds of load balancers.
There are.
What are the main ones?
Well, you've got hardware load balancers.
Okay.
Those are physical devices dedicated to the task. Then there are software load balancers, which run on servers. And more recently, we've seen the rise of cloud-based load balancers, which offer a lot of flexibility and can easily scale up or down as needed.
So it's all about choosing the right tool for the job.
Yeah.
Whether it's a heavy-duty appliance or a more nimble software solution.
Yeah.
It's pretty amazing how much is happening behind the scenes just to keep the internet humming.
It really is. It's a complex system with a lot of moving parts, but it all works together beautifully.
Before we get too deep into the technical weeds, though, I wanted to highlight some of the cool details from the source our listeners sent.
Right. Networking Basics Simplified.
What were some of the fast facts that really stood out to you?
Well, one that I always find fascinating is DNS caching. Remember how we talked about DNS resolvers being like phone books? Well, instead of looking up the same number every single time, DNS resolvers can store frequently accessed IP addresses in a cache.
So it's like remembering a phone number you call all the time. No need to look it up every time.
Exactly. Saves time and effort.
Makes sense. Efficiency is key.
And speaking of things we see online all the time, what about those error messages? Everyone's encountered a 404 or a 500 at some point. Those error codes can actually tell us a bit about what's going on behind the scenes.
Oh yeah, those error codes, I've definitely seen my fair share. But what do they actually mean? Are they important?
They can be. A 404 error simply means that the resource you're trying to access...
Usually a web page.
Right. Usually a web page wasn't found on the server. It could be a broken link, a mistyped URL, or maybe the page was deleted.
So 404 means, oops, this page doesn't exist anymore.
That's a simple way to put it.
What about the 500 errors? Those always seem a bit more mysterious.
They do. A 500 error, it indicates that something went wrong on the server side. But the specific details, they're usually kept under wraps.
So it's like the website saying, we messed up, but we're not telling you how.
Pretty much.
Okay, so 404 is page not found, 500 is something's wrong, but we're not saying what. Got it. What about some of those other tools we hear about, like proxy servers, firewalls, and VPNs? They all seem to be about security and privacy.
They are. A proxy server, think of it as a middleman between your computer and the internet. It can help with things like anonymity.
Like masking your IP address.
Exactly. Firewalls are more like security guards. They monitor and control incoming and outgoing network traffic based on preset rules.
So they block any unwanted connections. Kind of like a digital bouncer.
That's a good analogy. And then you have VPNs, virtual private networks.
VPNs. Those seem to be all the rage these days.
They are. VPNs, they create a secure encrypted tunnel over a public network like the internet.
So even if you're using public Wi-Fi, your data is protected.
Right. It's like traveling in a private car instead of a crowded bus.
Yeah.
Much safer for your data.
Makes sense. So proxy servers for anonymity, firewalls for protection, and VPNs for that extra layer of security.
Got it. Our source also mentioned something called packet switching and TTL.
Yes, packet switching is how data actually travels across the internet.
Instead of sending a message as one big chunk, it gets broken down into smaller packets. Each packet has its own addressing information and can travel independently across different routes. And then at the destination, all the packets get reassembled.
Wow, so it's like a digital jigsaw puzzle.
I like that.
What about TTL? What's that all about?
TTL stands for time to live. It's a value that's attached to each packet that determines how long it can survive on the network.
So it's like a self-destruct timer.
Exactly. It prevents packets from endlessly circulating if they can't find their destination.
Okay, so packet switching breaks the message into pieces.
Yeah.
And TTL makes sure those pieces don't get lost forever. Pretty clever.
It is.
You mentioned earlier that TCP is all about reliable delivery.
Right.
Is there another way to send data that's maybe faster, but not quite as reliable?
There is. It's called UDP, User Datagram Protocol.
UDP.
Unlike TCP, which checks for errors and makes sure everything arrives in order, UDP, it just fires off data packets without any guarantee of delivery.
So TCP is like sending a registered letter, and UDP is more like sending a postcard.
That's a great analogy.
You never know if it'll actually get there,
Mm-hmm.
but it's faster and simpler.
Exactly. And they each have their own uses. For example, for things like video streaming,
Ah.
occasional dropped packets aren't a big deal.
Makes sense.
So UDP is often used for that. But for something like a file transfer where every bit of data is important, TCP is a better choice.
Got it. The right tool for the job. One last thing that caught my eye in the source, dynamic IP addresses.
Ah, yes.
What makes them different from the regular kind?
Most devices these days are assigned dynamic IP addresses.
Meaning?
It means they can change periodically. It's a bit like musical chairs for IP addresses.
Yeah.
There's a central hub called a DHCP server that manages all these addresses and assigns them as needed.
So it's like having a temporary phone number that can change from time to time.
That's a good way to think about it.
But why do we need dynamic IP addresses?
It helps to conserve IP addresses,
Makes sense. With so many devices coming online these days,
especially with the ever-growing number of devices connecting to the internet.
we've got to make sure everyone has a seat at the digital table.
That's a great way to put it.
And speaking of making room for everyone, you mentioned earlier that we're transitioning from IPv4 to IPv6.
Right.
Why is that transition so important?
Well, IPv4, the older system, it uses a 32-bit address space, which puts a limit on the number of unique IP addresses available.
So it's like a small town with a limited number of phone numbers.
Yeah.
Eventually you run out as more people move in.
That's a great analogy, and that's exactly what's happening with IPv4. We're running out of phone numbers for all our devices.
Yikes. So what's the solution?
IPv6 to the rescue. It uses a much larger 128-bit address space.
So that's like upgrading from a small town phone book to a directory for the entire planet.
Exactly. IPv6 provides practically an unlimited number of addresses for the foreseeable future.
That's a relief. We definitely need that kind of capacity for all the devices we have now and all the ones coming online in the future. It's amazing to think about how much complexity there is in the seemingly simple act of connecting online.
It really is. It's a testament to human ingenuity and the power of collaboration.
Absolutely. We've covered a lot of ground today, but this is just the beginning.
There's so much more to explore. The internet, it's constantly evolving.
That's what makes it so fascinating.
Yeah.
But it's also important to remember that behind all the technology, there are real people.
Absolutely. The human element is essential.
So while we're geeking out about IP addresses and protocols, let's not forget the impact the internet has on our lives and on society as a whole.
That's a great point. We'll definitely delve into that in our next deep dive.
Stay tuned for that, everyone. We'll be right back after a quick break.
Welcome back to the deep dive. Before the break, we were really getting into the nitty-gritty of networking.
All those protocols and addresses, yeah. But I think it's time to step back a bit and talk about what it all means for us, the humans who use this incredible network every single day.
I like that, bringing it back to the human element.
It's easy to get lost in the technical details,
It's true.
but at the end of the day, networking, it's all about connecting people, sharing information, and making our lives easier in so many ways.
Exactly.
Like even just knowing the difference between HTTP and HTTPS, that little S at the end of a web address,
Right.
can make a huge difference when you're entering your credit card information online.
It really can. It means your data is being encrypted,
Mm.
so it's much safer from prying eyes.
And VPNs.
Yeah.
Those aren't just some tech buzzword. They're an actual tool that anyone can use to protect their privacy online.
Exactly. Especially important when you're using public Wi-Fi. You never know who might be snooping around.
That's true. A VPN, it's like having your own private tunnel through the internet.
I like that analogy.
Yeah.
A private tunnel keeping your data safe and sound.
So understanding these basic networking concepts,
Yeah.
it's not just about geeking out over technology. It's about empowering yourself to be a safer, more informed user.
Absolutely. Knowledge is power, and that's especially true in the digital world.
Okay, so our source, Networking Basics Simplified, it focused mainly on the technical side of things.
Right, the nuts and bolts.
But I'm curious about the bigger picture. The internet has completely revolutionized how we communicate,
For sure.
how we learn, how we work, even how we think.
It's incredible when you think about it.
What are some of the societal impacts, the ripple effects of this interconnected world we live in?
Well, on the one hand, we've seen incredible benefits.
Like what?
Instant global communication, access to information like never before, the rise of online communities that connect people across borders and cultures.
It's really shrunk the world in a lot of ways.
It has, but of course it's not all sunshine and rainbows.
Right. There's a dark side too.
Exactly. Misinformation spreads like wildfire online. Online harassment is a serious problem. And the erosion of privacy, that's a big concern for a lot of people.
It's like we've opened Pandora's box.
Yeah.
Amazing potential, but also some real risks.
I think that's a really apt analogy. And it's important to remember that technology, it's not neutral. It reflects the values and choices of the people who create it and the people who use it.
So it's not just about understanding how the internet works,
Mm,
but also how it's being used.
exactly. And the impact that has on individuals and on society as a whole.
We have a responsibility as users to shape the kind of internet we want.
Absolutely. We're not just passive passengers on this digital journey. We're active participants, and our choices matter.
So despite all the challenges, what's one thing that keeps you excited about the future of the internet?
That's a great question. For me, it's the potential for continued innovation and positive change. We're still in the early days of the internet, really. There's so much more to explore, so many problems to solve, and so many opportunities to create a better future.
I love that optimistic outlook. It's easy to get bogged down by the negative, but it's important to remember that the internet, it's a tool. And like any tool, it can be used for good or for bad.
It all comes down to the choices we make.
Well said. To our listeners, we hope this deep dive has given you a better understanding of not just the technical side of the internet, but also its profound impact on our lives.
We've just scratched the surface today, but there's always more to learn.
So stay curious, keep exploring, and be an active participant in shaping the digital world you want to see.
Until next time, it's a journey we're all on together, and it's a journey that's much more rewarding when you understand where you're going and how to get there.
I like that. It's like having a map and a compass for the digital world. And this deep dive has definitely given us a better map of the internet, from the technical nuts and bolts to the broader societal impacts.
We've really covered a lot of ground today.
We have. And I think it's amazing how these seemingly invisible technologies, they have such a profound impact on our lives.
It's true. We often take the internet for granted, but it's truly a revolutionary force.
It really is. I mean, it's easy to get caught up in the everyday uses like checking social media or watching videos. But the internet, it's so much more than that.
It is. It's a tool for communication, for learning, for creativity, for connecting with people all over the world. It has the power to change the world in so many ways.
And with that power comes responsibility, right?
Absolutely. We all have a role to play in shaping the future of the internet.
So for our listeners out there who want to be more informed and empowered digital citizens, what advice would you give them?
I'd say never stop learning. The internet is constantly evolving, so stay curious, keep asking questions, and don't be afraid to dig deeper into the topics that interest you.
That's great advice. The more we understand about how the internet works, the better equipped we are to use it safely and responsibly.
Exactly. Knowledge is power. And in the digital age, that power is more important than ever.
Well said. To all our listeners out there, we hope this deep dive has inspired you to learn more about the amazing world of the internet. We've only just scratched the surface today, but there's a whole universe of information out there waiting to be explored. So stay curious, keep learning, and thanks for joining us on the Deep Dive.